Hi, everybody. Welcome to another JetBrains webinar. This time we're doing TeamCity partnered with ClearMeasure. So before I introduce our guests, let me do the typical housekeeping here that we do at JetBrains. So um, first of all, thank you to the folks who are already in the YouTube chat, asking questions, telling us a little about yourself. Please continue to do so. If you're watching this live, feel free to ask questions in the YouTube live chat. If you're on Twitch too, you can ask questions there, and I'll try to get to those questions. Be sure to ask them because we'll be asking our guests today those questions near the end of this presentation. So if you have anything that you're interested in, just kind of picking his brain about, please ask it in the question. So the biggest question that typically gets asked on these webinars is this session being recorded? So if you're watching this live, but you still need to step away, life happens sometimes. Don't worry, you can pick right back up where you left off. And you can also see the live chat, which is a nice feature of YouTube. So on that note, let's welcome our guest today. He is the Chief Architect at ClearMeasure. I was actually going through a lot of his accolades. He's a YouTuber, podcaster, founder. So Chief Architect is underselling our guest. So on that note, let's welcome Jeffrey Palermo.
Good morning, good afternoon, good evening to everyone. Khalid, how are you doing?
I'm doing pretty good. Yeah, it's a good day. The sun is shining outside. I'm ready to learn about CI/CD pipelines from a chief architect, dev expert in the community. So, on that note, I can get quiet, give you the stage, and monitor the chat for any questions.
All right. Well, thank you very much, and I appreciate everyone's time. Um, and I wanted to, I was looking forward to this particular topic because for a long time I focused on DevOps in general and how to do software well, how to set up software engineering teams for success, for a frictionless work environment, to be able to decide what to change, actually make the change, new features, and get it through environments all the way to production with as little fanfare as possible. And one of the tools that has been a mainstay in the industry for a long time is TeamCity, and the recent acceleration of the product development at JetBrains for TeamCity is really, really awesome. And we'll touch on some of those things, but more so, this topic is how to put the pieces together, what the shape of a DevOps environment for a particular .NET application should really look like. And so that's what I'm going to go over. And just a quick touch on what ClearMeasure is. We're a US-based software architecture and engineering firm, and we're a consulting partner with JetBrains for the US for .NET teams. A little bit about myself. I live just outside the city of Austin, Texas, and my hobby is amateur dirt bike riding, and that's my boy changing his dirt bike tire after a flat. He done some races as well. And some of my history with TeamCity goes way back to when it was first released. And here's a quick snip of a blog post way back in 2007 when TeamCity first came out, and they were really working on some of the new capabilities. And at the time, the teams that I was running were using cruisecontrol.net, and we were using NANT for build scripts. And I know this is ancient history for some of you, but it goes back a long way. And TeamCity was the first to put a really intuitive designer on top of this whole process, where before that it was just a whole bunch of configuration files and everything was in text editors. So that was a huge step up from an experience perspective. And of course, over the years, ClearMeasure and JetBrains have had a great relationship, and we've done different things together. Here's just a few things. 2015, 2016, where we did some webinars together and some joint blog posts, and then in 2016, I wrote an article for Code Magazine that also talked about TeamCity and DevOps and how to do it in a cloud world. And an offer. If anybody's interested in my latest book, .NET DevOps for Azure, if you just send me an email, I'd be happy to send you an individualized electronic copy of the book. Be happy to do that. I'm gonna kind of skip over the clear measure way, but because I'm gonna talk about it as it relates to DevOps and how to move fast, how to build with quality, and run your systems with really high stability. So let's get into TeamCity. And if you haven't really used it before, there's 3 editions. Let me demystify this for you. There's TeamCity Professional, which has been around the longest, then TeamCity Enterprise, and those are the SKUs that you're going to install on your own environments. And then TeamCity Cloud is the one I want to highlight because that is the newer version of it, but it basically leapfrogs again GitHub Actions and Azure Pipelines, because for a long time Azure Pipelines, and then of course with the acquisition of GitHub, they boasted the hosted agents, and that was a really interesting feature. And the talk was, oh, when is TeamCity going to get hosted agents? Well, with TeamCity Cloud, now you have hosted agents, but you also have the tried and true design experience where you don't have to know every little bit of syntax of the specialized YAML files or whatever syntax is used in order to make changes and participate in the DevOps environment. You just have that beautiful design experience, which I'll show you in a little bit. And so when you look at Azure Pipelines and GitHub Actions, and I know intimately, I'm the host of the Azure DevOps podcast, which we've expanded in breadth, and several chapters in my book go through Azure DevOps. I know that product intimately, and the YAML experience is basically editing text files with some IntelliSense. Whereas with TeamCity, you have that from 2007 onward UI that has been honed and honed. It's just really easy to work with. So if you haven't looked at TeamCity in a while, then I encourage you to look at it. If you haven't checked out the TeamCity Cloud Edition, I encourage you to check that out. And there is a new version that's in preview that is going to be very, very imminent, and that is TeamCity Pipelines. Whereas it's a new, fresh look at how the experience really should be for a complete CI/CD pipeline, not just the builds and chains of builds, but holistically. So it's a brand new visual pipeline editor, and of course, everything that you do in TeamCity can be committed in its own special .teamcity folder in your Git repository, so that it's branch friendly, so that you don't have a global configuration if you need to make some changes based on a feature branch. So there's a URL right there that you can sign up for early access. And I want to give you some statistics. If you don't pay attention to some of the developer industry surveys out there, there's a state of continuous delivery report, and this is from May of 2023, and the couple of interesting data points that I wanted to highlight is the DevOps technologies used in the past 12 months, and the rate of self-hosted CI/CD tools has decreased, meaning everybody's moving to cloud. That's interesting. TeamCity has cloud, so you might want to look at that. Also, people who use CI/CD tools are significantly less likely to be low performers than those who do not. And that's kind of like the double negative wording, but the high performers use multiple CI/CD tools. Okay, so if you're not using build servers at all, or if you don't have it completely configured, if you don't have code coverage tools, then it's probably going to make it hard for you to deploy to production at least weekly, sometimes multiple times a week. You can see the chart in the middle of the deployment frequency. And there's still a lot of teams that are deploying less than once per month. That's too slow, folks. You need to get faster. You need to get faster. Okay. I'm not saying that every team needs to do multiple deployments per day to production, because there's a lot of teams where you're not going to have really anything significant for your users, every day anyway. They couldn't consume changes. I get that. Very, very few teams are actually the high volume e-commerce sites where you're going to deploy something that's going to make a little tiny tweak to marketing and it's going to make a difference. We get that. Most of us work on software where we know our users, and our users have a workday schedule, and they come to work and they use our software, and then they go to, and so maybe once a week frequency is the pace of your business. But whatever the pace of your business is, you need to have the engineering capability to deploy at that cadence. Okay. You need to go the cadence of your business and not slower than the cadence of your business. That's really the main point. All right. So let's get into the demo. I do want to provide some URLs at the top, and we'll make sure to share these. But we have a GitHub repository, which is a complete example. You can pull down all of the code that I'm going to show you, github.com/clearmeasurelabs. And you can actually also go to the TeamCity cloud instance that I'm going to show you, clearmeasure.teamcity.com. We've set it up for guest access so that you can just register as a guest, and you'll see the project when you go in, so that you can kind of browse around and see how it's configured. Because we understand if you've never put together a chain of builds before to represent a DevOps environment, then it can be a little bit tricky. You don't know what knobs to turn and what buttons to press. But this demo application, which I'll show you just here in a minute, is a very, very simple ASP.NET Blazor application on top of SQL Server. Nothing special per se in the .NET application. It's the development and deployment environment that we've created for the application that's important. So we'll kind of dive into that. All right. This is the TeamCity dashboard that will go in a minute. There's some pretty screens in TeamCity. It's been around a long time, but we're not actually going to go through the pretty screens. I want to walk you through how to put the right structure together. The structure is important. And this is the architecture that you're going for. This is the architecture. Now, we start out with continuous integration. Continuous integration has 3 different stages. And all the way back to 2006, when the book, published by Addison Wesley Publishers, named continuous integration. When it came out, it basically took all the debating and the conference discussions on what would it mean to integrate frequently or even continuously. And that book still stands the test of time. There hasn't really been a book that replaces it, because it really hit the nail on the head. And continuous integration is 3 things. 1, it's your private build in the commit stage. 2, it's your integration stage at the team level with an integration build. We've ended up calling it the CI build. And then the 3rd stage is your first deployment. And those 3 stages make up the pattern of continuous integration. Okay, we haven't given anything to our users yet, but that's the pattern of continuous integration for a particular team. Each of those 3 stages answers an important question. The first question, and over here at the commit stage, at the private build stage, do you know you're ready to commit some changes? Well, the answer to the question is, I just made some changes to some code or some configuration, whatever, in my Git repository. Do I still have a stable code base, or have I broken something? How do I know? And if I commit the changes that I just made, am I going to break my software, or do I still have a stable code base? Okay. Your private build answers that question. So your private build should do the compiling and linking. Of course, in .NET, it's super easy. .NET.exe build, and that does the compiling of C# and pulls it all together into DLLs and make sure you're good from that perspective. And as long as you set warnings as errors, that's going to be a very rich answer. And then, of course, we need to run local tests, unit tests, component level integration tests, tests that can be run against just the code in a non-deployed environment. And that gives you the satisfaction to know that, you know what, I haven't totally hosed my code base with this change that I made. And it's not a waste of time to sharing it with my team. The second stage, the integration stage, we have an integration build, whereas I take the changes that I just made, I send it over to my team by pushing it to the Git repository. And then we have our build server powered by TeamCity, and it pulls my changes along with other changes from other team members, and it answers the question, with the new changes combined with all of the other recent changes, do we still have a stable code base, or did we break something? That's a very important question, because I might not have broken something, but the combination of what I changed with another teammate, that might have broken something. And so we need to execute the same steps as in our private build, the unit test, the component level integration test, probably some more static analysis rules to get to that answer. And at the end of the integration build, we are satisfied that, hey, we still have a good step forward with the software. So let's package up a release candidate. Let's stamp it with a version number. Let's get our NuGet packages together, because those are needed down the road for the third stage, which is the first deployment. It makes no difference if we made some changes to the code and we package them up, and we think that, oh yeah, the build is green, if it won't deploy, if it won't start up. And we all know that tests can run just fine and the DLLs can be great, but when we deploy it somewhere, it's totally hosed. Okay, that's possible. So that's why we have the third stage of continuous integration, which is, will it actually run? Will it start up somewhere? And so the third stage is the first deployment. And the first deployment can be simple. It could be just, starting it up right there local on a local environment. Or if you're running in a cloud environment, a really great thing to do is to have a scaled down version of your production environment, auto created by Azure ARM templates, just at a lower CPU level, a lower memory level, but the same shape as your production, just a lower scale. And then make sure it starts up, because if your configuration is hosed, it won't start up, or if it starts up, but some of the main features no longer work. So that's really important. And then after that, now we need to deploy it to a manual test environment or a staging environment, then onto production. And TeamCity orchestrates all of those steps. Now you think, oh, TeamCity is a build server, and we need to also deploy to Azure. We need to deploy wherever our environment is. And so with TeamCity as the brain of your DevOps pipeline, you're going to integrate other products. If you're doing really heavy SQL Server database stuff, you're probably going to integrate products from Redgate. There's all kinds of great products out there. For observability, you may integrate Honeycomb or Splunk, or one of those APMs. TeamCity serves as the brain or orchestrator of your entire DevOps pipeline, and then you just integrate the other products where they make sense, where you need them. And so on this diagram, we have Octopus Deploy as doing the actual deployment, and it's another best of breed deployment software. And TeamCity has first class steps that go against so many best of breed products, and they work really well together. But this is the shape that you're going for any given application in Git or anywhere. This is the shape you're going for. You want your private build, your integration build. You want to package up whatever your application is, ready for deploying with release candidates. And in the .NET world, we store those packages in a NuGet package manager, whether hosted in TeamCity or hosted on your own somewhere else. And then we have a chain of deployment builds. So all of these steps that we chain together are a build chain. Okay. Now, I'm going to get into all the details, but there is a step-by-step implementation guide that is a part of the Git repository, and it shows you how to hook all of these things up. And I encourage you to go through that. It goes through in painful detail, and it goes through all these steps. Now, I want to give you one bit of admonishment. If you come from a centralized source control world where you had dozens of software applications in your TFS or Subversion version tree, and a certain folder was a particular application, and you have recently moved over to Git, don't put that entire tree in one Git repository, or even two in one Git repository. Make sure you have one software application per Git repository. Every product in the DevOps world is really designed and tested to work on everything that is in a Git repository. And kind of there's an underlying assumption that everything in that particular Git repository should be built together, should be tested together, should be deployed together, and thought of as architecturally one piece of software. And one piece of software in .NET is a Visual Studio solution. And it's perfectly fine if you have a web application, a backend job, a SQL Server database, 3 individual web API projects, and you could have 4 or 5 processes that need to be deployed for your whole application. That's fine. Architecturally, it's still one versioned software application. Okay. So I just wanted to stress how important that is. Don't make the mistake of having multiple applications with different directories and different Visual Studio solutions in a single Git repository, because you're going to end up fighting against TeamCity and the tools just because they really weren't designed or optimized to work in that situation. Okay. I'm going to come back to some of this after, and I want to show you TeamCity right now. Okay. So if I go over to browser, all right, we have clearmeasure.teamcity.com, and we have our application. Now, if we go to our build chains, then we can see that we have 3.233, and I'm actually going to go to one that I pushed through completely, and this is kind of what it looks like, just to visualize one that's gone all the way to production. And what we do is we start out by having the integration build, and then there might be 1 or 2 steps, 1 or 2 builds between our TDD environment. Now, TDD, that's our acronym for the test automation environment. That's what I like to call it, just to differentiate, because people call environments all kinds of things, and there's lots of people that have a quote dev environment, which is a manual test environment for the developers so that they can manually test it. But we need an environment that is no humans allowed. It's only for test automation. It belongs to the continuous integration process. It is the environment where we can deploy a brand new build, a brand new release candidate to this environment, spin it up, run some full system tests, however many we have, and make sure that that new build actually starts up, actually still does generally what it's supposed to do. Not comprehensive, but that we didn't just do something that totally hoses it. Because how many times do we deploy something to a manual test environment? We tell some of our colleagues in product management or in testing, hey, build number such and such is ready to go. They open up the first screen and it blows up in their face spectacularly. And they're kind of like wiping all of the goo off their faces. It's like, oh, this totally blew up on me. And we think, what do you mean? The build was green. And they say, well, it doesn't work. And then you say, wait a minute, what are you seeing? And there it is, a spectacular error screen. The application does absolutely nothing. And it's embarrassing. Why? Because our build was green, but something in the configuration, some little variable that needed to be just so, somehow went awry. And the result is the application's flat out broken. So we just need this little step. And that's why continuous integration has 3 stages. And the third one is ignored by so many people. We need to deploy and start up, and at a minimum smoke test. It's like click a few buttons somehow and see if it smokes, see if it catches on fire. And so that's what this environment is for, test automation environment. And if you have a web application, well, then Selenium or Playwright are fantastic tools to be able to, if it's a web application, open up a web browser, click around the application, run through the main screens. Even just the surface area, make sure it's not completely broken, because you don't want to waste the time of the people who are doing manual testing for you. If with this little step. All right, and in between, you might have a build stage, a build configuration between your integration build and the first time you deploy, if you need some particular steps to be done on a hosted agent of a different operating system. Okay. Now, from a technical perspective, we could merge these two, but in this case, it happened to be convenient. Let me tell you why. It was a good demonstration. The integration build, and I'll show you the configuration in a minute. We go through it. Is on a Windows agent. For this particular application, some of the database migration tools are happier on Windows, and for .NET that happens. Even with .NET 7 and the Linux compatibility, there's plenty of useful tools in the build stage that have long histories that are just still happier on Windows than Linux. And it's probably going to be that while for a few years, and that's fine. That's just kind of the way it is. The application itself doesn't give a rip, but some of the tools that you use, maybe static analyzers or database migration tools, in this case, they're just happier on Windows. And so we have that running on a Windows agent. And then the next stage, all this does is Dockerize the web application. Okay, because we're using Azure Container Apps for the web application, and then a serverless Azure SQL for the relational database. And so that's why we have this on a separate build chained together, because this is running on a Linux agent, and it does the Dockerization, and it's really quick. Okay. So we have the test automation environment in the TDD stage, and then we have UAT, which is deploying to a manual test environment. And you see, we branch off. We branch off because our test automation environments, especially in the cloud, those are really cheap. And we automatically create them for a new build. We deploy, we make sure it doesn't smoke, it's all good. And then we immediately carve off, and we have another build chain just to destroy it, because we don't need to even let it sit around consuming cloud usage. We just destroy it. And for the next build, we recreate it again. That's actually a really good pattern anyway, regardless of cost, because you're going to have 2, 3 of your developers working in parallel. And TeamCity does just fine running multiple builds, multiple integration builds in parallel, and that's no big deal. But if all of them finished in a similar time frame, and then all of them were trying to deploy to the same named environment in Azure, you're going to get a collision. Or you'd have to configure TeamCity to do one at a time, and then developer 2 and 3 who first in line, they would have to wait to see if what they just did hose the application from a deployment perspective. Well, if you're doing trunk-based development, which, by the way, if anybody is not familiar with trunk-based development, it's all it is really short-lived feature branches. Okay, you do your little change in your feature branch, and no branches live more than a day. Okay, so regardless of jargon, if you're using really short-lived feature branches, then these builds can run on what you commit and push to your feature branch, and you can have a test automation environment per feature branch automatically spun up for you. You can make sure that what you just did still deploys, still starts up, still generally the application still works, and now you have confidence to pull request your changes over to your master branch. All right. And so after we're done with the TDD environment, we destroy it. And then we go over, we push over to our master branch, and of course, UAT and production. Those only, we configure those to only pay attention to changes on the master branch. And of course, UAT is for testers or product management. It's a manual test environment for them. And by the way, you can have as many manual test environments as you need for your organization. If you need 2, if you need 3, fine, go for it. But you need at least 1, okay? At least 1. That's the minimum. And then everybody has production. And then in TeamCity, we have a build at the very end just to bring the 2 branches together, and that basically is just a termination point for a build chain. Okay, it doesn't actually do anything with the software. It's just a termination point for the build chain. Now, let me go into each one, and let's kind of dive in. Let's show you how it's configured. All right, let's just go into this one. Let's edit the configuration. Okay, I'm going to highlight a few things. I'm not going to highlight everything. I think we're going to hide unconfigured, so you can see these are the only things that actually have something special in them. All right, now TeamCity has it's probably the richest, most complete build server technology out there, given the history, and it has just support for absolutely everything under the sun. So don't worry that for your particular application, you're only using a sliver of the features or the capabilities. That's just going to be how it is. Okay. So in version control, this is super simple. We just point it to our Git repository. That's it. Okay. And then in build steps, we have 3. And actually, step number 1 has recently gotten really, really simple because a SQL Server engine has recently been added as standard to the build agents. And so it's there. And all we have to do is enable local DB, which we don't even have to use SQL Express. Because the engine is there, we run a command line and we just enable SQL local DB, and we have a super simple SQL engine for our build. And so if we look at this, it's just a little bit of script, and this can be put in a PowerShell file, but for demo's sake, it's actually simpler to show it to you just kind of right here. But this is all it is. Boom, SQL local DB start. Okay. And now we have a SQL engine ready to go. And then the second step is running build.ps1, which I'm going to show you, which is in our Git repository. Now you can add individual build steps like build a .NET application and .NET.exe and in-unit runner specifically in here. And yes, all of the configuration will be put into your Git repository. However, because you properly are going to equip your developers with a private build, you're already going to be laying out in regular script the basic steps to compile and run your fast tests. And so you already have that PowerShell script. You can just plug it in here. Okay. All right. So let's look at that over in Visual Studio, build.ps1. And over here, this is the first time that you've seen this Visual Studio solution. And just so that you believe me, I'm going to hit Control F5, and we're going to run this nothing of a Blazor application, but it's built out into a Visual Studio solution that's realistic. And so we saw, you didn't see this, but we saw the application spin up. And because I'm running the webinar software, it's running a little bit slower. Okay, started up here. And now we're on port 7174, which should be popping up right about there. And It's a Blazor application. All right, everybody's so impressed. Now let's get back to Visual Studio. Okay. All right, so build.ps1. This is what it is. By the way, if anybody has seen the previous webinar, which was like 7-8 years ago, this file is going to look pretty similar, except it just had different tools. And the structure of this file even goes back to a pretty popular NANT build configuration with cruisecontrol.net, where you put all of your commonly changing parameters at the top, and this build script becomes pretty darn portable from .NET application to .NET application, because what do they all need? Hey, what's the name of the project? What's the project that has our unit tests, integration tests, our full system acceptance tests? What is our startup project, which is typically a UI project? What's the path to our database project? And then we have some environment variable massaging here, where if the script is run on a build server where we're passing in one of these variables, or one of these variables is found as an environment variable, well, then we suck it in and use it. Otherwise, we use the defaults, which is perfect for a private build. Okay, so in that way, this script is useful for an integration build and a private build. And what are the things we do? Well, we do a little bit of initiation, which is kind of like cleanup, which is, hey, let's go ahead and delete directories, create directories, and then we do a .NET clean, because we don't want any of the old files from a previous build running around. .NET restore. Now, doesn't .NET.exe build also do restore by default? Yes, but you don't want to do multiple .NET restores because they take time. Think about it. We're calling .NET.exe for compiling. Then we're going to call it for our unit tests. Then we're going to call it for our integration test. If you just accept all the defaults, you're going to end up going back to the NuGet package manager 3 times. And the second of those is just going to be meticulously checking all the versions and reporting back, nope, I don't need to do anything. But you just wasted your build time. Okay. So do it one time at the very beginning and be done, and that will optimize your build time. Okay. So we do it here, and then we're ready to compile. And let me just shrink that down. And by the way, yes, this particular setup is kind of the way you want to do it, regardless of build server that you're using. So it's portable, but .NET.exe build, here's the solution name, and we say, don't even bother with restoring. We've already done it. We are pulling in the verbosity from the top, and here's a hint. Here's a freebie right here. Treat warnings as errors equals true. Most developers that I talk to, and of course I've experienced it too, don't turn on warnings as errors, and they just leave it off. And then we think, oh, you should do it. Oh, but why don't people do it? Well, because it's annoying. I'm trying to get something done. Yes, I understand I have the syntax. Yes, I understand that thing is deprecated and I need to go to something else. Yes, I know that I need to clean this up, but I'm just trying to get something working. And I've got Visual Studio right there, literally not even letting me run the function that I'm working on, because I've got some warning there, but I just need to get it working. I'm not sure if I even want to go to this direction. I'm just trying to get it working, and Visual Studio is barking at me because there's a warning and it's being treated as an error. And so in frustration, I just go to the project file and I turn warnings off just so I can see if this is going to work. And then it works. And then I just move on. Of course, I don't remember to go back and re-enable it, because then every single day I'm disabling it, re-enabling it, disable it, re-enabling it. And everybody out there listening to this, yep, all of you are nodding your heads, because that's the way it goes. So the better thing to do, we're going to turn it off anyway, just in the normal working. Okay. Especially with non-nullable configurations in the latest versions of .NET. I mean, there's like massive numbers of warnings that are popping up. And so we're leaving treat warnings as errors off at the project configuration level, just so that we can get things going. But when we run our private build, because we override that property at the solution level right here, we're going to get the benefit of not committing code, not sharing code with our team if we actually have warnings still left. Okay. So this is how to properly treat warnings as errors. We understand that you're not going to leave them on, but turn them on in your build. And that way, every time your teammates share code, it's totally clean. There's no warnings left. All right. All right. We're passing in the version number. This is also important because we want every single DLL stamped with the version. I mean, how many times, if you just look, I guarantee if you haven't intentionally looked at this, go grab some DLLs from your production environment and look at the properties of the DLL. They're going to be version 1.0.0.0. If you haven't intentionally done this, all right, you haven't intentionally passed in a version number. Okay. And all right, so that's compiled. Then unit tests. For unit tests, .NET.exe test. Again, we are no restore. And then if you're not collecting the code coverage metrics from running your automated test, just go ahead and do that. It's pretty darn simple. And coverlet collector with the cross-platform code coverage configuration, that is pretty good. And if you don't even know what coverlet collector is, I did a podcast episode on the Azure DevOps podcast on code coverage, and that was pretty interesting. We kind of went in depth on that. Integration tests are next, and we do it here, and we're pointing it at the integration test project, and that's pretty simple. Okay, and then full system acceptance tests. I do like to run them locally frequently, just so that spin the application up locally and run through. No need to wait for the build to finish and then wait for the actual deployment to Azure. You can run them locally. And so it's pretty darn simple. We're going to start .NET.exe as a separate process. We're going to pass in run. We're going to run our UI project, our UI CS proj. And again, we're going to do a no restore, no build because it's already built. Right. So that's the magic parameters there. And then this is a nice little PowerShell trick, push location. And then we're in a new directory. And from there, we can do .NET.exe test for our full system acceptance tests. And by the way, just so you know what these full system acceptance tests look like, they're pretty darn simple. We open it up. Here's one for the counter page where we're just clicking a button. Literally, we are using a CSS selector to look for a particular button. Yes, I've given it a ref attribute for click me button, and then we're finding it, and we're using the Selenium WebDriver. We're waiting until it actually finds the element, which takes some number of milliseconds, but it's not instantaneous, but still pretty quick. And then we are, let's see, click right there, line 46. And notice line 37 and line 47. Every time we do a full system test step, take a screenshot. File storage space is so cheap, it's basically rounds to free. And anytime you have these full system tests, from time to time, they're going to break. But why did they break? Well, if you just take a screenshot every time you do something, you won't have to run it manually through and say, oh, where did it break? You'll know because you look at the screenshot of what you expect and it'll be painfully obvious and it'll save you a ton of time. So again, another free tip. All right, so let's go back. I'm not going to go through all of these, but the code is right there available for you. All right. Now, another important step, there's too many settings here to go through, but another important step is how do you chain the builds together? That's the magic that makes a build configuration into a DevOps pipeline. And I'm really excited for the TeamCity pipelines configuration because it takes this that you just kind of have to figure out how to do it and chain the builds together, and it makes it a first-class citizen. Okay. So how do you do it? Well, let's go up to the project. You have to go to the second build. So if I go to, actually, I like to go back up here just to show you where we are again. All right, these are the builds in our chain. And so Docker build and push needs to automatically happen right after integration build. So let's go there, and I'm going to edit the configuration. Okay, let's go to dependencies. This is how you chain builds together. So a snapshot dependency is going to basically declare that I need to be bound and take a dependency onto the integration build. And there's a few parameters that tell it what to do. Okay. I'm gonna kick off and trigger based on an integration build, but the version number and every particular configuration variable that build number of integration build ran with, I need to have access to as the second build in the chain, right? And with that, you can have a pretty much unlimited number of integration builds going on different branches, and this will always do the right thing. Okay, so that says I need to snapshot everything on the integration build and have it available to me. Now the artifacts, this dependency says whatever the path for the artifacts of integration build is, I want that to be available to me as my working copy, as my working directory, because I don't need to have a cloned Git repository from GitHub as my working directory. I need to have the artifacts from a previous build as my working directory so I know where those things are. And so the artifacts path is the build directory of integration build, because the build script that ran in our CI build actually put all the stuff there. Okay, so now we have it. Because if we remember, the build steps for this is Docker build and Docker push, and we're pushing this up to the Azure Container Registry. All right, that's it. Now let me go to the next one. Let me go to the TDD build, and this is going to depend on Docker build and push. All right, so dependencies. There we have it again. See, the TDD environment is after we're Dockerizing our application. And so we have a snapshot dependency on Docker build and push, but we have an artifacts dependency on the integration build, because the integration build created the artifacts, not Docker build and push. So that's these two concepts that create your chain. All right. And then you have, all the rest of them, build steps are pretty self-explanatory. Yep, we're going to create and deploy release by calling over to an Octopus deploy step, and of course have API keys are grayed out and all the Octopus stuff. And then because we've created our environments automatically, we're going to run a little bit of script to get the container app URL that was just created. Then we're going to download our acceptance test package, the full systems acceptance tests, and then we're going to run them. Okay, so there's a lot to go into here. Let me switch back over. And I've talked about the structure of the private build and the integration build. I'm going to move over. This is the structure of your pull request process. And if you're working by yourself, you're going to still benefit from setting up a DevOps environment for yourself. But if you have multiple engineers, you have multiple people that are making changes, this is going to be your inner team loop right here. Right before you change some code, you need to decide what you're doing, and specifying actual test scenarios is the most concrete way to say to identify the bounds of what you're changing. If you have a happy, whatever you're doing, there's going to be a happy path through, and there's going to be an exception path. There's always two, and sometimes there could be 2 or 3 or 4 exception paths, and those are tests. Whether you need to check those manually, those are test scenarios. But if you can make full system tests for those scenarios, then you save time. Then you change the code on your workstation. You run the private build on your workstation. You git, commit, and push. And then on the build server, we're going to do our integration build. And then in our TDD environment, we're going to do our first deployment to make sure that the application starts up. We're going to run our automated full system acceptance tests. And then when that finishes, back on your engineering workstation, you can be confident that you can create your pull request. And whatever your team does, from whether I understand that some teams have an engineer approve their own pull request just for documentation, and others have a different person, whether named or whether group, kind of look it over. But whatever you choose to do, the pull request, don't skip, don't not do pull requests. If you're going to do feature branching, just do a pull request. It's free and amazing documentation around a unit and group of commits. Because if you just merge some commits back into your master branch, well, then you just have like a bunch of food ingredients, thrown on a plate, and it's like, well, what are all these ingredients? Well, if you look at it a certain way, it's a strawberry shortcake. All right, we need the pull request, the recipe that kind of packages it all up so that it looks like a strawberry shortcake. All right, and then once you have your pull request, let me go back. I really like to use the pull request checklists, and I advise teams to do that all the time, so that when a second person or even yourself is looking at the pull request, you as a team have decided on the checklist, have decided what you're going to do as when code is ready to be merged back into master, and that inspection just kind of elevates the level of rigor against problems. All right, I'm going to blaze over the Octopus configuration part. I've done other webinars on that. There's plenty of content there, but you saw the Octopus deploy was integrated with TeamCity, and when it's all said and done, you kind of have the full chain all put together, and working like it should. All right, let's see. All right, let me go back to here. Okay, there's a lot of knobs to turn and buttons to press, but this is the shape that you're going for when you're equipping a piece of software with a fully automated DevOps environment. And Khalid, there's bound to be questions around this, and there's different nuances and different decisions that can be made. If anyone would like this is the top third of a high resolution, print quality DevOps architecture poster. If anybody would like a high resolution PDF copy of this DevOps architecture poster, you can just send me an email. I'd be happy to send one. But I'll pause. We can kind of go to the questions, because this is the most important piece. However it shakes out, this is the general shape that we want to end up with.
Yeah, there's a lot to chew in that presentation. So, the thing I got right off the bat was like high performers use CI/CD tools, which was interesting. Did that graph say only 26% of teams actually use CI/CD? I think that's what the graph was saying.
Yeah.
Which is
for that particular survey. I think most teams are still just trying to get their software to work and make headway.
Yeah, so that was interesting. But yeah, like I couldn't imagine working in a big team without CI/CD. So,
Right.
Another point that I thought was really cool at the beginning of your presentation was you got to give users time to absorb the changes. So find the cadence of the business or organization that you work for and try to plan your deployments around kind of that absorption rate of your users. I
Mhm.
thought that was a really great point as well. Somebody asked, you talked about the 3 stages: private build, team or shared build, and then deployment. Um, where do you feel like you would run PR builds? I think you hinted at it at the previous slide, but this was asked early on, and maybe you could kind of reaffirm your answer there.
Ah, sure, sure. Um, so with with pull requests, I if you if you've already run through a integration, build, and then your full system tests, and you deployed it, then running another build at the time where you create a pull request is literally doing the same thing that you've already done,
Hmm.
um, with a slight nuance. Because I hear people like, no, it's different because it does it on master after merging, and that's all good. Once and so that can be useful if you find that you merge into master without it, and based on the nature and the number of people, some things end up with merge problems and things break.
Hmm.
Until what I find is until I find that I need them, I don't add them in automatically because that's just another 2-3 minutes delay on a particular cycle of getting a branch integrated. But if not having it ends up causing a build on master to fail and it could have been caught, well, then I would say, okay, in this situation, yeah, it's going to save us time because the breakages take more time. So
Yeah.
I think it's a choice. It's a tool. It's available if you want to.
Yeah, and I think that's kind of what you're hinting at throughout your throughout your talk, and I can definitely sense the passion and the scars when you when you give certain advice. I think it's going to depend on the organization that you're working at. Another interesting question that somebody asked, and you as a consultant, someone who's worked with a lot of teams, probably have good advice around this. This individual, I think Mark asked it. They have a monolith, and the build takes around 1 hour to kind of complete. Right?
Yeah, yeah.
Um, do you still think PR builds would be recommended in that scenario? What are some techniques to maybe get those build times down? Um, they suggested maybe they should just scale up to an infinite amount of build agents, and then all their problems will be solved. Right?
Well, I mean, an hour to build. Does that mean how much? I'd have to know how much it was taken to compile and how much it was taken to run certain tests. I mean, if all the time is going to tests, that's actually a good problem because you actually you actually know that when you make changes, you're not breaking things,
Yeah.
and tests are parallelizable. Now, maybe in the current configuration, if people I see it all the time. Some tests will not just be unit tests, but will rely on a set piece of data being there in a file system or in a SQL Server database, and so it's global in nature and therefore hard to parallelize. But you fix that problem, you fix that dependency, and then all of a sudden, I mean, technically, if you had 10,000 tests, you could do 10,000 build agents, one per. I mean, but uh, I'm guessing compiling doesn't take an hour. So it's
Well,
so it's other steps.
I have shocking news from you from Mark, who says
Oh, no.
basically no tests. So the build time apparently takes an hour, which yeah, that's interesting. Well, see, this is why clear measure exists, right? Like to help individuals solve these difficult
Yeah.
problems. Um,
I do
yeah.
remember, I mean, I would still guess that compiling doesn't take an hour, but I have seen where there's other tools that are necessary that, take 15 minutes in a pop. And then you
Mhm.
have this other tool that has to run, and so, but each of those steps, you just have to design it. It is a piece of software. A build is is a sequential piece of software, and
Mhm.
you need to just like you would design a screen. If you pressed a button on a screen, and it took an hour for that button to finish pressing and give the user what they wanted, you would decompose it, you would figure out what it was doing, and you would figure out how to get that button to press in, a very short amount of time so that the user would actually use it. So I I'm encouraged, Mark, that you're kind of diving into this and saying, okay, it needs to be better. Somehow we got to this particular path, but I just need to dig in. I need to understand and decompose what are the different categories of steps that are happening and how many minutes is each one taking, and decompose it, redesign it, and put it back together.
Yeah, that's great advice. I mean, the first step is just understanding your build process and where the time is kind of being sank. So, another individual asked a really interesting question, and I think it's really going to be organization based. But maybe you can give some folks some kind of insight based on the organizations you've worked for. They're asking if TeamCity can set like approvers for build promotion from one environment into the other, say like your UAT environment to production. Um, like, do you have any advice around doing that? Like, what have you seen other organizations do around that kind of process?
Around, help me understand, figuring out how to decide when to go from UAT to production.
Yeah, like, what kind of processes do companies put in place? Like, do they have a set of approvers? Do they do it
Okay,
automatically?
just the
Like,
approvers.
yeah.
So from a from a DevOps environment perspective, I found just having a approval gate configured to be universally useful,
Mhm,
and then having whoever it is in product management, whatever non-developer is, it's their job to decide, okay, now we're going to give version such and such to our users, and I'm coordinating with marketing or whoever is going to communicate to our user base, hey, something new is there now. Whatever person that is, I found it universally useful to let them be in charge of the decision to go to production. And sometimes that is, let them have an account on, let them literally have a TeamCity account and they can click the button. Or at least ask them, it's like, hey, I'm ready to click the button whenever you say. In other words, it's all automated, it's all ready to go. We're ready when you are. So that, and it's just communication. There's not a magic tool configuration. This is more about people, more about communication. If you just took away all of the high tech stuff and imagine that computers didn't even exist, and there were, and instead of deploying software, you were I don't know, you were deploying a new color of ink in the printing press. You had the bucket, and you're like, hey, you people who are doing papers, just let me know. I'm going to pour the red ink in here. I'm ready to go whenever you say. And they say go, and you pour the ink. I mean, that's the type of problem we're talking about. You just need to
mhm.
be coordinated with the people who are going to consume what you're pushing forth.
Yeah, and I think you made that point too earlier when you were comparing TeamCity to maybe some other build systems. Like GitHub Actions is a good example. It's very YAML based, so it almost isolates it to devs doing a lot of the work. But
Yeah,
you're right; it's a very social problem when you're building apps and including the people that also put their energy into the product, whether for marketing, design. I think TeamCity does a great job of kind of including those stakeholders. So,
yeah.
Stefano asked, I think you hinted at this, but maybe get a clear answer. Do you think setting up a build pipeline like you showed today, is it helpful for solo developers or small teams, like maybe two devs?
Sure. So um, if you analyze, if you just take in a spreadsheet and start to add up minutes, you can do this analysis for yourself to decide whether it's going to be useful. And by the way, in 2020, I I started a small software company that did livestock auctions. It was in partnership with someone I'd known for a while, and it was it was definitely a seasonal time because nobody was going out. They had to do these high school level FFA livestock auctions, but nobody was gathering at that season. And so, like, how do we do this online? And all that. And it was a fun project, but it was, I started it solo and then brought in one developer. So it definitely was one person and then two people. But if you think about the time that if you had no automation whatsoever, compile your software and hit Control F5 and measure how long that takes you and put it in the spreadsheet. And then how many times a day are you going to do that? Okay, put that in the next column. Then if you're going to run through all of the functions in the application, how long will it take you to test them? Okay, put that in the spreadsheet. If you're going to copy files over to Azure or run the Visual Studio's publish button and do that, how long does that take? Put it in the spreadsheet. And how often are you going to do that? How many times are you going to do it? If you're going to deploy it to production, then if you're going to go to production and you're going to test in production, how many minutes is that going to take you to do it? And then how many times per week or per day are you going to do it? And the time builds up. Okay. And so then what you're doing is you're trading the largely one-time hit of setting it up from scratch against the savings of not having the automation in place and just doing it manually. And that's just if you're perfect. Not to mention that something slips through and now we broke something and now I just boom, one of those and an hour is already down the drain, even for something small. Boom. Or 2 hours or 3 hours and like, wait a minute, I just changed two things at once. Which one broke it? So it quickly pays itself back. But if you have any doubts, just do the analysis for yourself and you'll see that quickly pays back. Most developers are really fast. Okay. Most developers are amazing. And it's not that it's why does management always wait for developers and say, oh, well, I don't know when they're going to have that done? Not because the developers aren't fast at coding. It's because they spend all their time doing things other than being fast at coding, spend time fixing stuff that's broken or wondering why the software works fine, but in production is doing something wonky. All of those things are something other than being awesome at coding.
Yep, it's true. It's true. And I'll also add like the thing you forgot to put in the spreadsheet was like having to explain every single step to someone new. Like
Yes.
automating these things cuts those kind of really low value conversations out of your team environment, whether it's 1, 2, 20 people. Automating it is just like the conversation's done, it's institutional knowledge now. We can move on and really discuss like important things to do as a team. So
Yes.
I would put that in my spreadsheet as well. So
Yes.
um,
And the hit of automating it at the beginning. The good news is I've spent loads of hours doing it personally over the last decade and a half. You don't have to. We'll share if I'm trying to put that in the comments. The URL to the GitHub repository. You literally can clone and copy and shred this Git repo, and it has a step-by-step guide. If you just go against your own TeamCity Cloud instance, put in your own keys and click, 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 and you'll have this shell of a nothing application with your own complete DevOps environment in your own Azure environment. And then you can just tweak from there. You don't have to figure all this stuff out from scratch on your own. So that's hopefully it's a time saver.
yeah, and I put the link in chat so folks can click on that. You also put your email out there. So if folks want to email you and get that
Yes.
DevOps book, I think that would be awesome for our audience today. Is there anything else you'd like to kind of tell our audience while we have them? I know you have a podcast, YouTube channel, but go ahead.
Yeah. The Azure DevOps podcast. If you search for Azure or DevOps in any of the podcast directories, I think we tend to always come up in the top 5 results, depending on which one you're looking at. So pretty easy to find. It's a weekly podcast, and then we are a US based .NET partner for JetBrains, and if anybody is having any issues, or would just even like some advisement or an inspection, we do that all the time for teams. So yes, we're available to hire. We have a good sized team, and we can help you get down the road. Our goal is to make uh, software project teams who are doing .NET projects highly successful. So if you're in one of those teams, our mission is to make your project amazing. Not come in and do your project for you, but to make you and your project amazing.
Yeah, that's awesome. That's awesome. So, I don't see any more questions, so maybe we can kind of start to wrap up here. Let's get my wind down here on. So, again, thank you to our guest today, Jeffrey. That was an amazing talk. Again, if you folks are out there looking for CI/CD advice, definitely check out Clear Measure. Just some amazing content there. If you want to learn more about TeamCity, you can head over to jetbrains.com/TeamCity. You can also check out the official product blog at blog.jetbrains.com/TeamCity. You can follow us on all the socials. You can also, I have clearmeasure.com here, so head on over there. Check that out. Jeffrey also is on X at Clearmeasure and on YouTube at Clearmeasure. And this is the part of the YouTube video where I say, if you enjoyed this, this kind of webinar, please head on over to JetBrains TV, like, subscribe, hit that notification bell, and leave us some comments. Let us know how we did and what we can do in the future. On that note, again, thank you to Jeffrey and Clear Measure, and we'll see you next time. Bye.
Thank you.